Okay.
Testing, testing, testing.
We're good.
Okay.
Good to go.
Yeah. If you want to ask questions.
Jeremy, tell us about Forward EDU.
Okay, so Forward Education, we started 10 years ago in physical computing and teaching design thinking. We try to connect everyday learning, after school learning, and physical computing really with real world technologies and careers to get students excited about a future in STEM.
So what are the topics that you would connect physical computing to that are real world?
Everything from like solar power to wind energy to electric vehicles. So we teach about the technology, let's say solar. They learn background on, what the industry is, potential post-secondary opportunities, and then they actually build and code a prototype of it. So with our solar kit, for example, they build a miniature solar panel that they then program to find and like follow the sun, and that'll actually charge the main board. And there's like a data streamer there so they can see, all the energy they've generated over a period of time. So kind of this like cool way that we take real technologies, real industries, and we shrink it down to a classroom scale and like get kids to experience it firsthand to get excited and, show them that they can do this too.
What other parts of the environment are you measuring with this?
What do we have? We've got a pH sensor, like a distal temperature sensor. There's a variety of different like small things like light sensors. So I think all told we have like 12 or 14 different sensors in our suite. Yeah.
And grade levels?
Primarily grade 3 to 10, but we're working on some things at the margin. I think more like high school level we'll continue to expand on.
So you're doing MATE code, right?
Yeah, primarily blocks and Python, but blocks is probably the bulk of what we do. Elementary, middle school is where we see the bulk of our kits right now.
So could you also take the same program and then translate it to Python?
Definitely.
With the same hardware and then use it for school and high school?
Yeah, and I think like Parallax, we right now are microbit only, but there is potential to do like Raspberry Pi. We actually did the Calliope board, so there's some extensions there too, yeah.
And is gaming part of it?
We do have one device, so we have what we call the code control, and we use that for a couple of things, either like MakeCode Arcade, so kids program their own video games, or we have a software called Microcode that came out of Microsoft Research, and that allows you to do like picture-based programming, so like Scratch Junior, if you will, for microbit or MakeCode, yeah.
And like, how do you distribute the curriculum online?
Yeah, so we got really frustrated with like off-the-shelf LMSs for like doing this kind of content. Everybody wanted like $1 per user per month, so we made our own LMS software from scratch. So we've